Hello class, glad you can join me on today's lesson on finding maxes and mins. And this one's going to be slightly different, that we're just going to try and start off with a problem from the get-go and see how we can tackle it. So, with this problem here, a rectangular cow pasture is being fenced in alongside a barn. With only 400 meters of fencing available, find the maximum dimensions of the fenced-in area. So I like this problem just because this is a very applicable problem for someone who works on a farm and tries to, optimize anything. And I'm going to say this also is classified as an optimization problem. And optimization problems typically work with using a sort of word problem that you're going to have to try and tackle. So take a moment and see what you can do, and then I'll go through it with you in a shortly. Alright, time to save you from your agony. So we're going to go through this, and actually, I would say if you're reading this problem, you're like, whoa, I have no idea where to start. Well, when in doubt, draw it out. So let's do that. Well, we're going to start off with just having our barn here. We don't need to draw the whole thing. We just have to draw one part of it because we're using one side of the barn for the fence. I'm going to extend my fence out here. And that's going to be my cow pasture. And this doesn't really have to be drawn to scale, just that we are trying to figure out what these sides can be. Now, in this case, I'm actually going to say that if I have this fence here, that I'm going to label these sides, which is, remember, we're having a rectangle, that these sides are equal, so they'll both be labeled X. And now we have to think about what's on this side here, this length right here, what is that going to be? Well, we don't have any fencing here, so we have X's here, two of them to be precise, and we have still 400 meters. So basically this is going to be what's remaining after these two are subtracted from 400 meters. So we can write that like the following, saying 400 minus 2x. Now with these variables we can actually solve for a fenced-in area. All we have to say is that given an area x is equal to 400 minus 2x. Remember, we're doing one dimension. We'll say the length here by the height, or length by width, whatever you want to call it. Vice versa, you can switch those around, multiplied by x. So this is going to give you some function which is 400 minus, x minus 2x squared. Okay, so if we're going to try and find this x, well, we notice we have a function here. And what type of function is it? Well, we see an x squared, so this must be a quadratic function. So let's sketch that. And we notice we have a negative coefficient with x squared, so it's an even function. We're going to get a behavior that looks like the following. So if we're actually going back to our problem, we'll see that we're looking for the max dimensions. Well, is there a maximum here? Well, yes there is. We have one right here. So we're going to solve that first by looking at f of x is equal to ax squared plus bx plus c. This is your base quadratic formula. Quadratic form of what you could have as an equation, and we have an actual application to find your maximum, which is x is equal to negative b over 2a. So let's apply that. So the x is going to be equal to, we're going to plug in here. Remember, this is not in the same order as this, so be careful. This is going to be negative 400 divided by negative 2 times 2. Oh, negative 2, there we go. So you're going to get negative 400. I put two negatives there. Let me get rid of that. It should be just 2 times negative 2. And we're going to negative 400 over negative 4, and you get 100. So that equals x. And that means that this is going to equal 100 meters. Okay, and now we're trying to find the maximum dimensions, right? We're looking for the dimensions. Well, all we have to do is now plug that into this right here. So 400 minus 2 times 100 meters is going to give you 400 minus 200, so this is going to simply be equal to 200 meters. And there you go. So you have your values for your dimensions to get the maximum area. Okay, let's do another problem. Alrighty, on to the next one. Squares with sides of length x are cut from the corners of a rectangular piece of sheet metal with dimensions of 6 inches and 10 inches. The metal is then folded to make an open top box. what is the maximum volume of such a box? If this is looking like you right now, have no fear. We have a tried and true method that works. When in doubt, draw it out. So when we're drawing this out, the first thing is I'm just going to start with saying that we have a rectangular sheet of metal here, okay, and that we're going to try to take out squares, sides length x from the corners. Well, I'm just going to do that in another color. We're going to be looking to cut here these edges off, or rather, yeah, these, sorry, not edges, but corners. Because when we cut these corners out, and I'll just shade that area, you'll be left with an area you can fold up and actually form a like bowl or some sort of metal cavity where you can actually have volume now rather than just an area. So we're going to continue this by labeling each one of these. Remember, they are squares, so if we label this X for one of the sides, this is also labeled X, that's X, that's X, 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 X. And now it's saying, what is the maximum volume? Well, volume here, if we actually, I'm going to draw a quick diagram what this should look like. Okay. When this is folded up, these edges will be the cut pieces we've done already. And should draw on the inside of there. Okay, so we want the maximum volume. What we have is X is going to be the cutouts. Well, that's actually going to represent it here by the height. Okay, so that helps us dramatically. And we have then our lengths and our width. Well, that's actually already helpfully given to us. We're already given some information that this is 6 inches. That's the shorter side, so this whole thing here is 6, and this whole side here is 10. I should label it inches. There we go. So these are inches. So we're going to label this further by saying we have the height, which is h is simply equal to x. Width is going to be equal to, we had 6, but we can actually write this with x's to say it's going to be 6 minus 2x. Right, because it's all based on x. So we have that. So let me actually cross out this. It was 6. Now we have it 6 minus 2x. And we're going to have the same thing for the length. I'm going to do a cursive because I'm used to that. Is equal to 10. And again, we're going to say this can be just 10 minus 2x because we have those two sides cut out. I'll cross this because it's no longer 10. All right. So now we have our 3 dimensions here for h, w, and the L, which is length. So let's put this into an equation here. V of x for volume is equal to length times width times height. So length times width times height. And now let's plug in what those are. So we have v of x is equal to length, which is 10 times 2x, multiplied by 6 minus 2x, multiplied by x. Oh, how fun! Now, I will be honest. This would be a pain in the butt to do by hand, so we are actually going to use a calculator for this. So, if we end up graphing this in Desmos, we end up saying that v of x, the volume, is equal to 10 minus 2x multiplied by 6 minus 2x multiplied by x. So you're going to get this cubic function, okay, with end behavior up here and down here. And we have a maximum and a minimum. Notice I didn't highlight the minimum because you're not going to have a negative volume here. If you have a negative dimension, think about it. What's going to happen? You're not going to have a box. So really, your box can only exist in this domain here, from the here to here. Okay? So we look at our maximum here. Our max is going to be 1.214. That's your x value to yield a volume that is 32.835. So I'm going to simply say that your x here is going to be equal to, I'll use this color here, is equal to 1.2, and then we plug in 1.2 for the other two to get those dimensions. And you get 3.6, and 10 minus 2 times 1.2, you get 7.6. And those are your dimensions in inches. Don't forget your units. And actually, I think I should take that back because it's asking for your volume here. So your maximum volume is actually going to be this output, which is 32.8. Always read the question, guys. So V of x is equal to 32.8, and don't forget your units, inches cubed here for volume. Alrighty, well I hope you enjoyed this video. That is the end of this lesson, and I will see you all next time.